Good morning. I want to welcome you to today's webinar. My name's Linda Clausen, and I will be today's presenter. We're going to chat about profile tables in Db2. David Simpson is also in attendance today to help with any additional questions. Make sure I catch your questions, etc. Now, the webinar slides are downloadable from our webinar site at themusinc.com/webinars. The slides are already out there. Now, the recording for this session is usually posted about within 48 hours after completion of the webinar. So if you want to direct your coworkers to the webinar so they can listen in as well to what's being presented, you can direct them to the webinar site, and it'll be available for replay. Okay. Questions. If you have questions, you could submit them by typing in the question into the question area in the webinar control panel, or you can send me an email after the class. We'll answer what questions we have time during the session, and for those that we don't have time for, you can always send an email to me. My email address is there at lclausen@themusinc.com. The material in here is a combination of a couple of our classes, my DBA performance tuning class and the systems monitoring and performance tuning, because profiles can be used for monitoring distributed applications, but much more than that. Now, they came out in version 10. In version 10, we were able to do some distributed thread monitoring using profiles. In version 11, they expanded that into being able to set an override for the spatial registers for certain distributed threads. Now, most of your profile entries are meant for distributed threads, DBAT threads, distributed requests. Okay? They're harder to control than your local allied attachments. So being able to provide values to override so they don't need to change their code in a distributed environment is very handy. Where the local applications, they still have to do their own overrides if they don't like what the default values for their spatial registers are. In version 12, those lovely global variables they added in version 11 for the archive tables, we can also issue sec commands to override the archive enabled table global variables for controlling that archive processing. Now, historically, and people tell me this, well, have you looked at profile tables? And they say, well, that's just for the analytic processing. I said, no, it's not just for the analytic accelerator. There's a lot of things I can do with my profiles. There's a lot of things I can do in monitoring my distributed threads and my distributed connections and narrow it down to a specific group of distributed threads that are causing the problems and provide overrides to my ZPARMs for the number of connections and the number of threads, those distributed requests, and the action taken for those bad actors. I can also use profiles to set up overrides for the subsystem parameters, the properties to make my test subsystem think it is the same size and the same speed as my production environment. So the access path optimizer, when it goes through its mathematical algorithms, uses that higher processor speed and those larger stores to create their access paths. So yes, they're used for the analytic accelerator as to when to ship it off, but it's used for much more than that. So when we look at profile tables, you have two key main base tables. The first one, the DSN profile table, is where you insert a row and define the scope or who you're wanting to set up a profile for. And then there's an entry in there, profile enable. You will enable it, yes. Now, if you want to go back and disable it, you just update the row and make profile enabled no and reload the profile table, and it's turned off. So you can turn it on and off with the enable column. Then after you define who, you're going to tell Db2 what you're going to monitor or what you're going to do. By inserting one or more rows in the profile attribute table. And yes, you can have more than one attribute row for each profile you set up. Now, the function you want to perform is in the keyword column in that attribute table. And then if the attribute or the function you want to perform is a string, you put the value in the attribute 1 column. If it is an integer override, then you'll put it in attribute 2. If it's a floating point, you put it in attribute 3. Now, Db2 keeps history of these profiles. So after you remove a profile, it's still out in the history. And that's for diagnostics. So something happened a while back, and it shouldn't have. Well, it could have been because of a profile that was turned on and then removed from the profile table. Those old profiles are kept in history for diagnostic purposes. Okay, so you can see, oh, that's why it happened. Now, the basic sequence of events that you're going to do is you're first going to set up and insert a row in the profile table. So you insert the scope and you enable it, yes. Then you insert the appropriate keywords and keyword and attributes in the attribute table. Once you've done that, then you can issue the start profile command, and that will load or reload your profile table into memory, and at that point, it takes effect. Okay? To deactivate an individual profile, you could update the profile table, set the enable profile equal to N or no, or you could delete the unwanted row, which will put it in the history. Then you need to reload the profile table with the start profile command. So now that takes effect. So that's how you set them up and turn them off. Now the profiles, when you're talking about the profiles, it depends on the type of profile you're setting. Okay? The keyword. As to the type of scope you can define. So each one of these individual keywords that you're specifying, there are limited numbers of scopes you can apply them to. So you have to look that up very carefully. So I'm going to set up three different profiles. The first one is based on location. So any distributed thread connecting to location DC1A, profile ID number 20, is a location profile. Now, you can get your location IDs and narrow your locations down if you want to, if you're monitoring per location. Just do your display locations or look at your trace record, what locations that you want to look at. Your trace reports, those, they're coming in, connecting to the location. You can set up, if you've got a group of applications that they are calling from a remote location and executing those applications within a collection, you could put the collection ID in there. So you can set up collection profiles. Depending on the type of threads you want to monitor, those threads executing that collection of programs, you're going to set some overrides for. So you can set up collection profiles. So an example of a collection profile is in collection number 21, profile ID 21, collection ID, profile is enabled. And then you can set up a global profile that applies to everybody. Now, you can do very minimal things in a global profile because most of the profiles are geared for a distributed DBAT thread. Now, we're going to look at the individual ones as we go through this. But I've set up profile number 99 as my global profile. So that I can set subsystem overrides for making my test subsystem look like prod. It's basically the purpose of that. So I've got three profiles. Now, if you don't supply a profile ID individually, say, hey, I'm profile number 20, Db2 will do it for you because the profile ID column in the profile table is an identity column generated by Db2. So different things you can do. Now, monitor remote connections. Let's assume that the locations either are coming in from IP address or domain name through there. You want to monitor the connections. Now remember, there is a subsystem parameter, a zparm, that specifies the maximum number of distributed thread connections. However, for this location, you want a warning if those connections are hitting too many connections. That location is trying to get too many connections. And nobody else can connect because of it. Because they're driving you up to your subsystem max. But you do have a group that you want to get a warning on, or you could even abort them, cancel them if they're getting too many connections. It could be a flaw in the way they're set up, and their connections are staying around too long and nobody can get those connections. They're not terminating appropriately. So what you could do is you could set up for that location, use the key for word in the attribute. I'm going to monitor the connections for that profile, location profile. And I want you, Db2, to either just give me a simple warning And when it hits attribute 2, the maximum number of remote location connections from that location coming in, that IP, or that domain name coming in through that domain name, you want a warning. And once it's hit, every 5 minutes, it's going to come back and say, hey, these guys can't, they're waiting. They're not allowed to get another connection. Or if they hit the attribute 2, you can say exception. And if you say exception, then those threads will abort with a negative SQL code. Let's see, it's trying to remember what the SQL code is. It's a -2 some in the 2000s somewhere in those. Too many connections. And it won't let them sit and wait forever. Start canceling them out. Now, diagnostic level. Warning is just a dumb warning. Level 1 gives you a little bit of diagnostic information. Detail, diagnostic level 2, if you want real detail, you would use diagnostic level 2. And it gives you a long, wide all the diagnostic information about the connection that exceeded what you wanted your limit to be. Now, threads is where I'm really more enthused about, let's put it that way. I can set up a profile for distributed remote threads, these DBAT threads that hang around forever and don't go away because the front end did not, in their statement, in their trans. And it's sitting out there on my active thread chain, sitting there forever, can't stop Db2 because it's not going over to the inactive thread chain. So I can narrow that down, and it could be by location only or product ID. If you know the product ID, it could be a JCC product identifier. And if you're unsure, just do display locations asterisk, and it'll show you all the product IDs that are connecting into your locations. Or I could narrow it down to, if they're using a common authorization ID, auth ID, I could say anybody coming in on that auth ID, if it's unique to that group of processes, or it could be a client application name that is the cause of those long-held threads out there on the active chain that never go away. And I want to monitor those threads. So it could be client user ID or client workstation, or it could be a collection, a wildcarded collection, collection prefix asterisk, package within collection, or both. Or if you're using roles, you can say, hey, this role, if they're assigned to that role, these are the ones I want to monitor the threads. These are the ones that are using keep dynanim, which means their thread stays on the active chain even though they commit, or they've done things like cursor withhold and didn't close the cursor when they committed, and the cursor is still maintained, and they're out on the active chain when they should have closed the cursor and then committed. They didn't end their statement properly, and they didn't, before they committed. Those types of things, where we have questionable coding techniques out on the front end, and we can't change it. Could be because it's a purchased product, and they just didn't think in Db2 for ZOS the difference between a type 1 and a type 2 thread. And I got a bunch of these type 1s that sit on the active chain. Stop me from recycling Db2. They're out there forever. I'm tired of going out and canceling them. So I could do some monitoring of those specific threads. And what I'll do is I will put in however I can identify them as the scope in my profile table. And then I will insert a row in the attributes table for monitor threads. And I'll put a value in attribute 2. I'm only going to allow a certain number of remote active threads sitting on the active chain before I either start kicking out warnings, messages to the console, or aborting them, kicking out an exception. Now the SQL code on that, if you do choose exception, that one I remember. It goes down with an SQL code -30041 is returned to the client. So there's threads out there that was aborted because they hit my thread limit for their individual scope, whatever the scope in the profile table is. So I can abort those. Now, we'll also get some diagnostic information. If it does, so we also get the console messages kicked out, either on the wording or diagnostics. Now, attribute 2 must be less than your ZPAR maximum active DBAT threads in the environment, of course. You know, but if the majority of the active threads out on the active chain are these types of threads that are hung around out there because they didn't terminate appropriately and not able to go over to the inactive chain for reuse of those thread task control blocks. So that is, max DBAT is your subsystem, all. Now, if they are hitting about 50 or 20, this specific client application is using up half of those, maybe I need to look at that application or leave this monitoring in there to boredom and not let them tie up all of my distributed threads. Get warnings, these are the culprits, and get diagnostics information about those culprits that are causing those problems, those ugly type 1 threads. For example, now, if we look at some of the examples, here I am going to monitor the thread, and I want a warning anytime profile number 21 exceeds 100. Now my ZPAR could be 500, but I'm saying, hey, look, if this specific group and 21 was a collection, was monitoring by collection ID. They're coming in and invoking that collection of packages. If they hit 100 threads out there, I want to know. I want some warning messages. Okay? Good chance they're not closing their cursors before they commit. They're not. We'll want to take a look at those. Or they're using keep dynam. If it's a Java front end that's calling this, and they've got keep dynam, which means it stays around on the active chain until they end the statement and end the trans. They stay out there on the active chain instead of being moved to the inactive for reuse, for thread reuse. Because I want to optimize my thread reuse, and I don't want these processes that aren't coded appropriately eating up all my resources. We can also monitor for the idle threads, those type 1 idle threads, differently. It's not just number of requests, it's they are sitting there on the idle chain. Idle threads are those threads that can't be, they're type 1 threads, they're idle, they've committed their data access, but they're holding some other resource and have not completed, such as they're holding a resource, they're a type 1 thread. They've done a cursor withhold and did not close the cursor before the commit, which means it has to hold that position. Or they've got a held lob, or they're keep dynam and they didn't end the statement, they didn't code the front end appropriately. To make keep dynam in a distributed environment effective, it means that they need to process the same SQL statement over and over and not be redoing prepares and preparing other statements. They need to end that statement, and in trans, it goes to the global cache anyway. And so if they come back in at a later time, rather than sitting on the active chain the whole time, they can refresh it from the global cache and reuse it from there. So when we're working with the keep dynam to make it appropriate, and the only time they should be binding keep dynam is that they've coded appropriately for it. And that's where we have some fall through the cracks. So I can monitor those idle threads sitting out there, and for a specific group, either a client application or a collection of packages they're invoking, or their auth ID or their product ID, I can set, instead of them honoring the zparm, I'm going to set up an active idle thread limit for them, so I can either get warnings that they're doing it or abort them, cancel them, throw an exception. So I can monitor the idle threads. So if I want, so attribute 2 is where you specify the threshold for those active idle threads, and whatever value you put in there will override what the idle thread timeout is in your subsystem zparms. Okay? Now, you could do it either direction. You may have your zparm set very small, and you have a small group of client applications that you need them to stay idle longer because they're complaining. Or it could be the reverse. You can set it smaller. Whatever you set, your idle thread timeout value for those client applications, that client application name, that is going to be honored. So it's an override to the zparm. And it could be greater or less than the idle thread timeout in your zparm. Unlike when we're doing max dbat overrides, or when I want warnings or exceptions, or the connection. Those must be less than the zparm. This one can be either direction. So you can set your subsystem idle thread timeout to what you really would like it to be, and then do a temporary override for some client applications if they're violating that rule, and you have to service them. You have to let them stay there longer. Darn it. I'd like to just blow them out of the water, but can't always do that. Have to make sure that your user environment is serviced appropriately. Now, in version 12, there was an enhancement added for that idle thread. If you set your idle thread for a specific set of distributed application coming in where you have to adjust, you don't want the zparm isn't appropriate, you need to lower or up it for that specific application group. You now can say, if you're going to terminate the thread, to go ahead Db2 and roll it back. Okay? So if it hits the threshold you set, go ahead and roll it back just to be on the safe side. Okay? And that rollback will clean up things like declared global temporary tables where there was a cursor with hold on it. They didn't close that cursor on the global temporary table. I mean, it's not data locks, it's resources out there that they're holding. Okay, so they didn't close before they committed or processed out. So it'll be a rollback, and you can get just simple rollback or a little more diagnostics with diagnostic 1 and in detailed diagnostics with diagnostics level 2, so you can get a better detail. Now, the other thing that has tripped my trigger or excited me is for my distributed threads, I can have, rather than the default spatial register value, I can set the spatial registers for a group of distributed threads. Now, could be, again, by client application, I want this to be the default spatial register contents, or for those packages and plans that they're executing, coming in through a distributed thread, I want this to be the spatial register, rather than the distributed application having to recode or do a set of the spatial register value. I want to do it for them. So the profile attribute keyword for those profiles, the keyword is spatial register, and in the attribute 1 is a simple set statement. So in attribute 1, you could say set the routine version to be this version identifier, or set the schema. So if you want them to point to a different set of tables, so you could set the schema to the new set of tables. Or you could, for example, change the path, add in a path for providing the schema name of a certain set of user-defined functions and stored procedures. Or if you're working with your temporal tables, you can change the value of the current temporal business time or current temporal system time, so they don't need to provide it in their SQL statements. So I've added a system table, and I want to set the current temporal system time to be current date minus 24 hours, so they always see it. And on the maintained, so these things they would normally have to code their program to set, we can do that. And another item, set current degree of parallelism. You have a few little packages out that are being called from the distributed environment, and they could take advantage of CP parallelism, but the ZPARM is set current degree 1, and they were not bound set current degree any. Well, I can set the spatial register to current degree any and let them get parallelism, because that overrides bind and it overrides the ZPARM default. So I can do these things. I can do overrides. I can turn on debug mode. And the first one, current application compatibility. Well, rather than having them have to do all the rebinds for their dynamic SQL programs that are coming in through here, if I want them to be able to use version 12, release 1, modification 501 or 502, I can do the current application compatibility mode, and those dynamic SQL statements will run under that Apple compatibility mode. So they don't have to do the binds. And the ZPARM could still be at 500, modification 500. So controlling, or I may have to take them back to version 11, release 1, because of the nature of the application. So I can do those kinds of overrides. For example, and global variables. Not only spatial registers, but as of version 12, I can also set the global variables. Global variables, those are the ones that were added in version 11 to control your archive-enabled tables. And how are you going to go out to the front end and say, okay, now, I took 75% of the data and put it in archive table. And I altered the base to enable archiving. So every time you do a delete, the row automatically gets moved. However, that is controlled by these global variables. So when you're doing deletes, you have to go in here and do a set. Well, no. For the local applications, it's fine. They're probably coded, they code it. But for the distributed, no. I want to turn it on automatically. So I can put out there for those client applications, however I'm going to define that scope of distributed threads, Db threads coming in, that are doing deletes to my tables, but I want the deletes moved to the archive for the older content. I can create a profile attribute, global variable, and I can set the move to archive equal to E for enabled. Then it still allows them to insert, update, or delete. Deletes will be moved. If you set it to yes, then any updates they do will fail. So be careful of what you set that move. And then you can also set the get archive to yes. So when they go out and do a query, moved rows, they automatically see it, whether it's in the current base or the older data where it's been moved for the less accessed. That data that's not transactional anymore, it's just there for query processing. So the get from our get archive global variable is the most important one, I think. Because usually the move to archive is done by a local batch process that does the purge. Maybe. Also, don't forget added now in version 12 is the temporal logical transaction times and temporal logical transactions, where that unused system temporal table column, that transaction, is now used. So whatever it's set to is the transaction time, and it carries through to all rows with that one common logical transaction, where the start and ending time in your history table for a system temporal table is the start and ending of an individual row. If it's a multi-row process, this would be the temporal current logical transaction time, okay? And support for logical transaction. So you could have, the first process is going to do the current timestamp, and all of the transactions within that multi-row process would have the same timestamp. So there's the block of transactions performed. So being able to control things a little bit better in system temporal tables. Okay. So some examples. Now, I have profile number 24, and 24 was my profile by auth ID. Okay, so I'm going to insert into the profile table my user ID. This user is giving me a headache, and I'm going to throttle them back or set certain application variables for them. So if they come in a distributed thread under my user ID, that auth ID, I have a profile called 24. It is enabled. I will start it. I insert into the attribute table, move to archive, yes. I would have preferred E. And I also put in there, I realized that after the fact, but I'd put the example in here. Get archive, yes. So any deleted rows goes to the archive set, the table, space table. And then when they do a select with get archive automatically set to yes, then when they do a select from the base, it automatically brings in what is in the base and the archive table. That had been moved out of the way of my transaction environment. So I can have control of these archive and archive-enabled tables. They makes it more usable. Okay? Makes it more usable. And there's a ZPARM defaults too. You can override. There's still a little problem with your archive-enabled tables. You still can't join a system temporal to the archive from my last testing. Anyway, I'm waiting for them to fix that. Or I shouldn't say fix. Put in the new feature to be able to do that. Here I have a profile number 20 set for location DC1A. I want the queries coming in where we connect to DC1A. The spatial register current degree equal any. I want to allow them to have parallel CP parallelism. Right now the default is in the ZPARM is degree 1. Okay? So it doesn't dynamically bind with degree any, allowing for CP parallelism. So a little tuning, performance tuning thing. They're going against these large partition table spaces. They're using DIPSY indexes. So parallelism, I want them to be able to use parallelism to decrease their elapsed time. A little extra CPU, but I decrease. Now, please note, DC1A, when I come in under my user ID and I look, I connected through I came in through user ID, my user ID. I connected through DC1A location, which happens to be the location of my Db2 subsystem in the Bootstrap dataset, my location name. Could have been put in there by an IP address. Okay. When I select to see what they're setting at from my front-end app, it happened to be Data Studio. I connected in through Data Studio and I did a select. Okay, what is my move to archive, get archive, and current degree settings? Well, we'll notice that both profile 24 attributes and profile 20 are in effect. You can match multiple profiles and they will apply in sequence they were created. So be careful if you've got two profiles you could match. It's the latest one that's going to take effect if they are in conflict. So make sure you don't have conflicting profiles out there. I like this stuff. I think you probably get an idea you do. Create acceleration. Now you can use the profiles, of course, for the analytic accelerator for query acceleration. You can set your current explain mode register to explain for those front ends. You would set the keyword to your accelerator name, explain, and then the attribute. That would be the name of the real or virtual accelerator. IBM, when they're helping you set the analytic accelerator up, will help you with this. So you need to get the information there from them. Same thing if you're setting up size of the table that you're going against. You're going to throw it over to the accelerator, or the assumed result size in the prepare. Oh, it's going to be big, so it's going to go to the accelerator, or the estimated cost during the dynamic prepare. It's going to throw it over to the accelerator. So these are the thresholds you would have IBM help you set for the analytic accelerator. And subsystem. This is the last group I'm going to talk about. You can do subsystem overrides for your distributed apps by plan, by subsystem parameter overrides for SQL. Actually, these can be global. Okay, you can say all plans. asterisk. Or you can narrow it down to certain collections or packages within collections. But if you want it for everybody, plan asterisk, collection ID asterisk, package name asterisk. And then you can do overrides. You can override the zparm num page threshold, which if the attribute to value that you put in there, if the volume of the table statistic says this table is this size or less, I'm going to go ahead and treat it as a volatile table. I'm going to favor index access. Because the table starts small, gets big, starts small, gets big. It's a volatile table, but the table definition isn't volatile. So I can do the end page threshold just for that collection of packages. I can turn on star join and control it through zparm overrides. The star join and the minimum star join tables, those zparms, where I turn it all off. Well, for a certain collection of packages, maybe I want, or a certain plan, maybe I want to turn them off. So we can do that. Or I can model test to match production. Now to do that, you need to go out and find, and it's moderately well documented, find out what your production processor speed is, CPU speed, okay, and the number of CPs in that CPU, which is probably different than your test environment. Your test box is probably a lower speed with less CPs, engines. So first thing you need to do is find out what the speed and number of engines, CPs, is on production. Then insert into your test subsystem zparm the two zparms, simulated CPU speed, okay, is whatever it was on production, and the simulated CPU number of processors, CPs. Then, once you've done that, then you're going to set up profiles, a global profile. That was my profile 99. Everybody is going to abide by that. How many? And make my test subsystem think that I have the same amount of storage for my RID blocks as production does. Make my test system think it has the same sort in memory storage size as my production does. And make my test subsystem think it's working with buffer pools, the same storage size allocated as production. Because whether you realize it or not, each of these items feeds into your access path optimizer. It is used in that mathematical algorithm when access paths are being chosen. So if you want tests to really reflect the CPU milliseconds and the CPU service units, as it would explain in production, you can get much closer on your test box if you make your Db2 think your test box is the same speed and size as production. So you can do this modeling and make fool Db2. Now I know it's not nice to fool Mother Nature, but in this instant it's good. Make tests look like prod. Not just the catalog tables, volume of tables, but the processor itself, the memory, virtual memory allocation. Make it think at bind time, and when you do explain that it has this to work with, this amount of resource. So you can set those global ones up. For example, my global profile was 99. Boop, that's for everybody. It's only allowed for these system-wide parameters. Goes subsystem-wide, doesn't matter if you're DBAT or local threads. And make Db2 think the buffer pool size for profile ID 99, buffer pool 0 is 25,000, buffer pool 8K0 is 2,500 pages, and do it that way. Now that's different. It gives a better access path than simulated buffer pools if you're using buffer pool simulation. So that is the basic presentation, just letting you be aware of the things that I found and a couple things that excite me using these profile tables.